Money FM 89.3, the best of the afternoon update. The afternoon update with Lynlee Foo.
That's right, you're with me, Lynlee, and this is Industry Insight on Money FM 89.3, where we explore the trends shaping business and industry today. Now, yesterday, we spoke about how liquid cooling is helping data centers cope with the surging heat and energy demands of AI-driven workloads. But what happens when even the most advanced GPUs and CPUs, however well-cooled, just can't keep up? Earlier this month, on July 9, Singapore became home to Southeast Asia's first hybrid quantum computer deployed inside a commercial data center, which is a significant milestone for the industry. So what does this mean for data centers, and how might it reshape how operators compete and innovate? Joining me to discuss this is Mayank Srivastava, CEO of BDx Data Centers, which launched the hybrid quantum system at its flagship SIN1 facility in Paya Lebar. Mayank, welcome to the show.
Thank you, Lynn, for having me.
Now let's get right into it, Mayank. The data center industry is already under a lot of pressure with the rise of AI workloads and sustainability targets. Why was now the right time to introduce hybrid quantum computing into a commercial data center setting?
As the saying goes, there's no better time than now. But I think the real relevance is that quantum computers are getting real faster than we think that they will get real. So, the intrinsic problem with the human mind is that it does not catch exponential trends very well. Linear trends all of us get. But exponential trends are difficult to dimension in our minds. And the way quantum computers is improving, and there's enough sort of literature available on this. Google has published a lot. Wall Street Journal even has gotten to publish stuff on this. Quantum computers are going to be real by 2029 or 2030. It is apt for a country like Singapore, which has been at the forefront of being the technology hub for the region, to start having a commercial deployment for the quantum computer for the industry as well as the startups inside of the country and around the region, to be able to access the quantum computer and have a lot of fun with the potential that the machine offers. So why now? Because now is the time it's taking off.
Okay, and I suppose Singapore, with its smart nation and green data center goals, it probably provides the perfect ecosystem to take this step at the moment. Now, for listeners who might not know, what exactly is a hybrid quantum computer and what does it bring to a data center?
So a hybrid quantum computer means that you have a quantum computer, an adjunct to the typical high-performance GPUs or CPUs. So the way to think about this is that quantum computer is very good at solving certain problems. But if you were to do a simplistic calculation, I'm oversimplifying it, but if you were to do a 2 plus 2 is equal to 4, you're not utilizing the quantum computer to its potential. Why hybrid? Because the hybrid ecosystem of a GPU, a CPU, and a quantum computer, the QPU, quantum processing unit, together create a very, very powerful computer which can solve a lot of problems which are already being solved very efficiently, and solve a lot of problems that today's computers, GPUs, CPUs, whatever architecture you put them in, they will take like millions of years to solve. So that is sort of the essence of a hybrid quantum computer. What does it do for the data center industry? For the data center industry, the hybrid quantum computer is a lot more efficient in terms of the per unit power of compute that a data center can put forward to for its customers. That efficiency of power consumption and the exponentially more output in terms of compute is really what helps the data center to partner countries and the ecosystem, which is cloud providers and enterprise customers, startups, etc., government research, to really be able to power, really be able to partner to power the country to continuing the leadership, the technological leadership.
Okay, Mayank, some critics say quantum computing is still experimental and not yet commercially viable. So what would you say to that?
So, and that is correct in parts, and which is why the quantum computer applications, commercial applications that are happening today, are applications which can live with what is called the error rate. So the applications for which the quantum computer is being applied or used today are applications which can live with that kind of error rate. As the error rate improves over the next 4 or 5 years, so today, for the listeners who are more sort of inclined on the math of it, the error is 1 in 1,000 operations. As over the next 5 years, this is predicted to go to 1 in 30, 10 to the power 30. So billions, trillions, whatever that number works out to be. So today it's 1 in 10 to the power 3. It will go to 1 to 10 to the power 30 in the coming years. And then quantum computer will be able to solve any problem much better than what you see, today's GPU clusters, for instance, trying to solve. So yes, it is not there yet, but there are applications which can still use the power of quantum computing even with the current sort of drawbacks, and which is why we have sort of launched the first commercial deployment of quantum computer in the region.
Okay, Mayank, just out of curiosity, tell us which industries are starting to build their quantum capabilities now?
Oh, so the industries which will benefit massively from quantum computing. So industries which have started today are, for instance, finance, pharmaceuticals. A lot of chemistry today is really up for grabs for quantum computing. Security, the current security protocols can be broken by quantum computers in like seconds. It doesn't even take minutes. And I can go into details on how that works. But the point is, these are the industries which are really looking at deployments today. In Singapore itself, we have startups who are doing great work on quantum security, for instance. And quantum security means that the communication becomes totally impenetrable. It is physically not possible to break into that communication. So these are the industries which are sort of early adapters for quantum computing. Now, as time passes, as quantum computers get a lot more efficient, quantum computers will be deployed in fields, in almost every field, but think of cosmology, think of weather, think of our understanding of evolution. And all of these things, while they sound a little esoteric, but they have very real life implications on the way we live, on the way we behave, and the future, what the future holds for us. So it is going to be, as it grows, a really, really revolutionary technology. Today we hear tons and tons about GPUs and AI riding on GPUs. Wait till we have quantum computing, and then you see where AI goes.
Wow, exciting stuff. Now, this hybrid quantum system launched at your flagship facility in Paya Lebar. Does this give Singapore and operators here an edge over other regional hubs like Hong Kong or Tokyo?
Undoubtedly. So in this region, what we refer to as Southeast Asia, this is going to be the first demonstration of commercial applications for a hybrid quantum computer. And in the Southeast Asian region, particularly Singapore, like I said earlier, to maintain its edge in this entire region, to be the technology bellwether, it sort of helps by leaps and bounds. I mean, there's enough quantum computer stuff happening in the labs all around, but the fact that this is the first commercial launch is going to be a magnet for businesses across the region to try and leverage the benefits of quantum computing out of Singapore.
Okay. Now, one of the criticisms of advanced computing is, of course, the massive energy use, and yet Singapore has set green data center standards. So how does hybrid quantum fit into the sustainability conversation?
Quantum computers' massive use of energy, and I had this debate with our partner, Anion Computing, which incidentally is a Singapore and San Francisco headquartered startup. And I had a long chat with Dr. Roger, who is the founder and the CEO of this company, and he actually seemed quite surprised as to, where is all this hullabaloo coming from for quantum computers being massive power guzzlers. Just to, explain the basic physics of how it works.
Okay.
The quantum computer works on the principle of supercomputing, superconductivity. What that means is that the machine operates at very close to minus 273 degrees Celsius.
Okay.
We try to dimension minus 273 in our minds. Singapore's ambient is between 34, 28 to 34.
Wow. Okay.
Greenland, the coldest regions in Greenland go down to about minus 50, minus 60 degrees Celsius. Here we are talking very, very close to minus 273 degrees Celsius. What happens at minus 273 degrees Celsius is that the electrons, which are sort of the carrier, the quantum particles, which are the carrier of information, at such low temperatures actually move with close to zero resistance. So when they move with close to zero resistance, there is no heat dissipation. They do not require power to move across the machine to be able to do the work that they have to do. So there is no resistance, there is no friction, so the machine gets infinitely more efficient, and the only power required is to keep the machine at minus 273 degrees centigrade.
Okay.
And that is the cooling that is required. You have hydrogen, nitrogen, etc. The power used is like orders of magnitude less for a like-to-like output from a traditional compute architecture. So GPU plus CPUs, if they were to get the same output, the power consumption is order of magnitude lesser.
Okay. So is that already happening at your Sin1 facility in Paya Lebar?
It would start happening sooner than later, and we will let you know as it kicks off.
Okay. And do you see regulators playing a bigger role here, perhaps even incentivizing operators to adopt these more efficient and advanced technologies?
I mean, absolutely yes. If I were to take a step back, the two industries which are crying themselves hoarse over being regulated, AI and data centers. AI because of the obvious implications that they can have on both the positive as well as the negative side. And data centers simply because, today we consume about 3% of the global power output. Eric Schmidt, who is the ex-Google CEO and chairman, and now he works a lot on AI. In his congressional deposition, he said that there is a possibility of data centers consuming up to 90% of all power on the planet.
Oh.
So it is really very, very important for both of these industries to be regulated. And the thing about regulation is that, regulation should not. So if you were to go out of the Changi Airport, Terminal 3, you don't actually have to present your passport for immigration, right? Regulations need to be as easy as that.
Okay.
Regulations need to make sure that the incentives are aligned. So incentives for every player in the value chain are aligned such that they are proportionate in some sense to the risk that each player is willing to take.
Okay.
So if we keep these 2-3 things in mind, I believe that regulations will actually have the growth of these industries to flourish rather than be an impediment.
Okay. Now, in addition to that, I'm sure talent and the ecosystem, that's just as important. So beyond hardware, the data center industry also needs the right people and ecosystems to make these innovations work. So how ready is the region on that front?
So the way to sort of think about it is in the value chain of an end customer being able to use a quantum node for their requirements. There is the data center, there is the actual quantum computer, and then there is a layer on top which helps to connect customers with these quantum computing services. All three of these parts of the value chain are actually solved in Singapore. The number of startups that you have in Singapore, Anion Technologies, our partner, being a Singapore startup, all of their technical staff actually sits out of Singapore.
Wow.
You look at the number of quantum startups who are working inside of the country is probably on a per capita basis the highest by far in the region. I mean, when I say region, I mean you can think of it from the Middle East to Japan. And in terms of the ability to be able to create a quantum cloud, if you will, to be able to convert that quantum computer into a cloud service to be accessed by startups, enterprises, etc., all of the big cloud players are more real in Singapore than they are anywhere else in the region. So people like Amazon, Google, Microsoft, etc., they have their biggest deployments as well as technical capabilities present inside of Singapore. So I think all of the three parts of the value chain check out in terms of readiness as well as talent availability.
Fantastic. Mayank, before we let you go, looking ahead to, say, maybe 2030, what do you think the data center of the future will look like?
That's an excellent question. The data center of the future, and of course it is going to be so much more energy efficient that when we will look back 10 years or 5 years, so when we look back at 2025 or look back at 2020, we would actually be looking at the dinosaur age.
Wow.
So, yeah, that's how efficient data centers are going to get.
Okay, any other trends you think operators should already be preparing for now?
I think operators need to get a lot more integrated into this whole sustainability story. People are making the efforts now, but these efforts are happening more because of regulatory pressure. And when I say regulatory pressure, I'm loosely using the term regulatory, but you have events like COP 26, 27, 28, whatever, annual events on sustainability. So people are acting under definitions that these systems provide, that these ecosystems provide. What the change that has to come is that all, especially data center operators, need to understand that we barely have half a planet left. And if we don't start feeling responsible inside of our hearts, we will never be able to get sustainability to be commercially accretive the way it should be. Today, majority of the ecosystem just sees ESG as a cost line item. The fact of the matter is that the industry, once it realizes, once people get this in their hearts that you have half a planet left, there will be nothing left probably for your grandkids. The industry has to put in the effort to make sure that all of these initiatives become commercially accretive. Otherwise, we're just checking the boxes.
Okay, thank you so much, Mayank, for your insights today. He is Mayank Srivastava, CEO of BDx Data Centers. Thank you so much for helping us understand how hybrid quantum AI and a greener, smarter future is important in terms of reshaping this data center industry. Appreciate your time.
Great to be there with you, and thank you for the opportunity.
Thank you. Have a good day ahead.
To listen to more great interviews, download our podcasts at audio.sg or download the audio app. That's AWEDIO, audio at the App Store and Google Play.